Hey guys, I'm sorry I'm not there, but I thought we probably need to go through just a little bit of a review of what we've done so far. We have a look at what we should have covered, apart from the background knowledge, which we did quite a bit on, and you remember our mixed bag questions where we did a little bit of everything. If you're needing help on those ones, the solutions are there and the video explanations are there, so I will leave you to find those yourself. You'll be able to see there on our OneNote page there, so that's not too bad. But let's quick review of what we did over the first couple of weeks. So we're going to start this review with arithmetic sequences and series and geometric sequences and series. Quick reminder of what they are. What are the key things I need to remember about arithmetic sequences and geometric sequences? Arithmetic, what's the basic definition? What's the one thing I need to remember? The difference between consecutive terms is constant. That's the actual definition. That's what we need to know. And we can use that to answer pretty much all the questions consecutive, trying to talk and spell at the same time. Sometimes a bit challenging for the maths teacher. The difference between consecutive terms in these sequences is constant. How do I write that in a nice mathematical way rather than having all those words on the page? Well, what we would say is that the difference is equal to un minus un minus 1. One term, subtract the number that came before it, the term that came before it. Sometimes you'll see that written as, instead of u's, remember we've talked about the fact they can use t's, and I could just as easily say tn plus 1 minus tn. They're equivalent statements. They're saying the same thing. One term minus the previous term, whether I call it n and n minus 1, or n plus 1 and n, doesn't really matter. What that means is if I have a list of numbers, the 5th minus the 4th minus the 3rd, the 39th minus the 38th, always give me the same answer. So that's what an arithmetic sequence is. That's pretty good. We should remember that. The geometric sequence, can we remember what that is? I'm sure we can. A geometric sequence. The ratio between consecutive terms remains constant. Ratio between consecutive terms is constant. How do I write that in a nice mathematical way again? Get our little blue pen out for the maths. So this time, instead of D for difference, I'm going to use R for ratio. That makes a lot of sense. So the ratio between two terms. So if I take term n and I divide by the term that came before it, that should give me the constant ratio. Again, if we're using T notation, remember the book can use either. In the exam you may be faced with either. Sorry, the book will use U. IB often use T. It doesn't really matter. We still get the same. It works the same way. It's arbitrary what notation we use. So that's okay. Arithmetic geometric sequences, not so bad. So we have rules for finding the general term of each one of these. So although we've got the basic definition of what they are and how they work, what would be the general rule for an arithmetic sequence? Well, you start with your starting term, which is U1, the first term, and then you have to add on the common difference. How many times do we need to add on the common difference? N minus 1 times, because of course when you start with the first term you want to have 0D, don't you? You don't want to have extra numbers added on. We then add on after that. So that's the rule for finding any term in an arithmetic sequence. That, of course, if you want to look at what the general sequence looks like, quick reminder, that would be U1 would be the first term, U1 plus D would be the second term. I'd add on my difference to get to the next term. The third term would be U1 plus 2D, and so on. And you can see that matches with the formula up there. That's all we need to remember. I'm pretty sure they're all in your formula book, so they're not too bad. Geometric, what's the basic or the general formula for finding one of these? So any term, the nth term, I take my first term, I multiply it by the common ratio, and again, it is n minus 1 times. So in this case, it's to the power of n minus 1, because obviously I'm not going to need to multiply the first term by anything to get the first term. It's just going to be what it is. So again, it's n minus 1. What does the general sequence look like? Didn't mean to scroll there. Sometimes it's hard to see where my pen is. Got it back, that's all good. What would the general sequence look like? I'd have u1 times r, u1 times r squared, and so on. That's the basics that we need to remember about arithmetic and geometric sequences. Got your general term. We can go ahead, for each one there, we can go ahead and we can work out all the problems based on that. I'll be back in the next one with series and what's the difference between our sequences and then when we talk about series. Cheers.